As I was looking through the mountains of research on Spinosaurs, I came across so many papers about teeth. Teeth may seem boring and unimportant to some, but they do help to fill out the ecosystems of the past when full skeletons are nowhere to be found. This is especially the case with Spinosaurs, since they loved the water. Their teeth fell out often and fossilized better than their bodies. That means they can tell us about where and when they appeared in deep time. Brazil seemed to be a hotbed for these critters, and a smattering of teeth show they were throwing their own carnival for tens of millions of years, and in some places, way before the Spinosaurs with names we all know and love. I want to show you what is known of these teeth, what those teeth might mean, and why they are special. So, come along with me. Hello! I've turned myself into primordial ooze. I thought it would be a fun way to transition between my voice, live action footage of myself, and cute little characters that fit the theme of the videos. I can use this talisman here stuck in my goo body to transform into any one of the edge totem animals. Tyrannosaurus, elephant, and Mothman. Maybe down the road, and if you like them, I can find out how to transform into even more critters. There are currently only 3 Spinosaurs known from Brazil. No named Spinosaurs are known from any other part of South America. The 3 known Spinosaurs are Irritator, known for a bizarre skull missing only the tip of the snout. Oxalaia, known only from a snout tip and a chunk of the mouth. And the dubious Angaturama, also just a snout tip. Despite how fragmentary all these bones are, they do preserve some good features scientists can use to tell them apart from all other Spinosaurs, hence the names. They prove that the Spinosaurinae chunk of the Spinosauridae group was living it up in the beginning of the late Cretaceous of the easternmost part of South America. Along with these 3 meager specimens, there are dozens of teeth belonging to both the Spinosaurine and baryonychine lineages of Spinosaurs found throughout South America, though mostly from Brazil. The presence of these 2 great groups of Spinosaurs might say something for the evolution of this group, but because they are all teeth, they cannot say much. In order to figure out what these teeth tell us about the saga of the Spinosaurs, I need to first introduce you to those teeth. They might seem boring at first. They're not charismatic skulls or sails or claws, but teeth are just as important. Teeth fossils can be used to get a tally of what groups of animals were around at a certain time and place. They can also be used to tell what those types of animals were eating. Isotopes from the matter they ate got stuck in the teeth, and they can help scientists tell what types of plants or animals they were eating. Slicing up the teeth, polishing the slices, and observing the slices under a microscope with different types of light can also help scientists to understand the age of the animal, if they had some weird bone illnesses, how the animal grew, and some of the structures of the crystals in the teeth can even help with identifying species. Spinosaur teeth have been found in South America for a while, with a few publications from 1999 to 2004 noting them, with one of the earliest publications to describe them by Manuel Alfredo Medeiros in the Brazilian Society of Paleontology in 2006. Medeiros described samples UFMA 1.20.070, 1.20.443, and 1.20.444 SL, which consist of about 275 complete or fragmentary teeth resembling those of Spinosaurids between 13 and 101 millimeters long, collected from an outcrop called Laje do Coringa, which is part of the Alcântara Formation. Out of these 275 teeth, Medeiros found that there were definitely at least 2 major types of teeth. Morphotype 1 is the most like those in Spinosaurine Spinosaurs, with light fluting along the tooth, wrinkles in the enamel covering with no serrations. And Morphotype 2 is also like Spinosaurines, but it's weird because the enamel coating is smooth with no wrinkles, and there seems to be a gradient between the usual conical teeth and slightly compressed teeth. Medeiros thinks this means there were more than one type of Spinosaur around at the time.
This is getting out of hand. Now there are two of them.
One more similar to known Spinosaurs then and now, and one completely unlike any Spinosaurs. And this has continued to this day, as no Spinosaur fossils have been found with that second tooth type lodged in its snout. However, there have been several other Spinosaur tooth finds in recent years that agree with this idea of many types of Spinosaurs living it up in Cretaceous Brazil. So why don't I bring you on over to that research?
Okay.
2016 saw the publication of a paper by Marcos Sales and colleagues in the Journal of South American Earth Sciences. In this paper, Sales and friends describe a single-tooth specimen found at the then-new fossil site Ganapistula 1. This site is an outcrop of the Feliz Deserto Formation, dating to between the Berriasian and Valanginian ages of the Early Cretaceous, 143 to 132 million years ago, the earliest of Early Cretaceous. Most of the fossils found at the new outcrop belong to crocs, but there was a single theropod dinosaur tooth found among these croc bones. This partial tooth, specimen LP-UFS 5737, belongs to a Spinosaur. The authors could tell it was a Spinosaur due to the cone shape, a smooth tooth root that is as fat as the base of the crown, a large pulp cavity, fluting of the tooth's crown, and unserrated carina on the curved side of the tooth. They also classify the tooth as belonging to the subfamily Spinosaurinae, since baryonychine teeth have stronger serrations, while Spinosaurines have little or no serrations. This identification makes it the oldest evidence of Spinosaurids and Spinosaurines in South America, predating or overlapping with baryonyx. There are reports of possible Spinosaur teeth and claws from Jurassic deposits in Africa, but they are so fragmentary and badly preserved that a strong ID of Spinosaur is open to interpretation. Same sort of goes for this tooth, but it preserves a handful of traits only seen together in definitive Spinosaurine teeth. Hey, mind if I just butt in real quick? Just throwing out a little reminder to subscribe and like this video. Share it around as much as you can. The more eyes, the better. A Spinosaurine in Brazil this early on in the Cretaceous implies that the Spinosaurids were in a lot more places earlier than thought. The Spinosaurs known from South America are mostly Spinosaurines, but they date to much later in the Cretaceous, when others of their group were common in North Africa. Spinosaurines in Brazil in the early Cretaceous could mean that they originated in South America, splitting from the baryonychines of Europe. It could mean that Spinosaurs are much older and were separated by the continents only to evolve into different lineages in isolation. It could also mean that Spinosaurines were capable of crossing the distance between Africa and South America and simply migrated from one place to the other. For context, Africa and South America were much closer during the early Cretaceous than they are today. By 2021, the Ganapistula 01 site had produced a lot more Spinosaur teeth. The new teeth were described by Paulo Aragão in 2021 as a thesis. Specimen LPUFS 5871 is almost all of the crown and a teeny bit of the root, and was identified down to the Spinosauridae family. Specimen LPUFS 5870 is a little bit better than the last, with all of the crown and a little more of the root. There are two lines of carinae, or the little teeth that line the sides of the tooth for better slicing. This tooth was identified down to the baryonychinae subfamily of the Spinosauridae family. Two more, LPUFS 5872 and 5873, are in similar condition to the other teeth, but they preserve features that help identify them as Spinosaurine Spinosaurs, the group that includes Spinosaurus, Sigilmasosaurus, and Oxalaia. This pushes back the entire Spinosauridae family to the early Cretaceous, possibly proving that the split between baryonychines and Spinosaurines happened well before the early Cretaceous, since both types were already around in South America and then in Africa. There was also proof of a very large early Spinosaurine near the end of the Early Cretaceous of England, the informally named Vectispinus. So this sort of all goes together with the idea that the two groups were palling around for a while before the baryonychines seemingly went extinct. Another school of thought has found that the baryonychine group might actually be a bunch of Spinosaurs that independently evolved similar traits, or that diverged themselves from different lineages within the group. The exact origin and method of dispersal for these animals keeps going back and forth between groups of researchers. Some have evidence that Spinosaurines originated in Laurasia and migrated to Gondwana. Others have evidence of the opposite. These teeth fossils are only teeth, so they remain questionable. Baryonyx is still the most unquestionable and stable oldest spinosaurid. A 2023 paper by Mauro Lassera and colleagues in the journal Cretaceous Research also described a bunch more Spinosaur teeth from the Ganapistula 1 locality in the Feliz Deserto Formation. They described 6 crocodilomorph teeth, 11 Neosuchian teeth, 1 indeterminate theropod, and 8 that they could whittle down to a Spinosaurine identification. These new teeth, combined with all the other teeth that have been described from the same spot, represent a pretty diverse deltaic lacustrine system of croc-like crocs and croc-like dinosaurs living together, going after all sorts of large fish, just like they were doing in early late Cretaceous Africa. The continuous flood of Spinosaurid teeth from this locality implies that Spinosaurs were relatively common. Sure, they spit out a lot of teeth relatively quickly, so that is part of why there are so many here, but the different tooth types might imply there were complex ecological things going on as well. I've had my frequent collaborator, literally Miguel, reconstruct a Spinosaur that represents what could have been living in the Feliz Deserto Formation. I wanted him to give it a head crest since all big Spinosaurs had something like it. Baryonychines seem to have had crests around the eyes, while Spinosaurines had midline crests. Since we are very early on in the Cretaceous here, I figure that whatever these animals looked like would be somewhat similar to what they looked like near the very end of the late Jurassic, as they diverged from their megalosauroid cousins. Thicker skulls, maybe? Or maybe they had already advanced towards fish-eating and water-living and already developed their skinny, kinky jaws, eyes on the top of the head, and nostrils pulled back towards the eye sockets. I want Miguel to go even more far out with speculation, so I forced him to give the darn thing a wavy midline crest that goes down further than most advanced Spinosaurine crests do. It starts where they do, but who knows, maybe some of these early forms were experimenting with display features on the head before the spine or tail. I mean, some paleo artists started reconstructing baryonychines with paddle tails, like Spinosaurus, because the tail vertebrae are mysterious and missing in many of them. So maybe it was a primitive feature they evolved early on. I don't know, I felt like since we are dealing with teeth here, I could have Miguel go a little crazy. Yes, it does also have feathers. There is no direct evidence of feathers in the megalosauroid part of the theropod tree, but since the megalosauroids were probably part of the Titaniurae group next to the carnosaurs and coelurosaurs, I think there is a possibility that Spinosaurs had feathers. Feathers are great for hydrodynamicity, as plenty of living dinosaurs can attest. Concavenator has quill knobs in its forearms, and then almost every non-bird dinosaur known with feathers is from the Coelurosauria group. Plus, it's also now pretty likely that feathers evolved before pterosaurs and dinosaurs separated, so I don't think it's that crazy here. I have a sneaking suspicion scientists will find bigger and better remains of Spinosaurs and Spinosaur-adjacent theropod dinosaurs from the very latest Jurassic period at some point. Bits and pieces have already been found, as indeterminate as those can be. The story of the Spinosaurs is far more complex than anyone can imagine, but paleontologists are teasing out the details of the story one find at a time. I hope to live to see the day that story is told. If you like this video, please leave a like, subscribe, and leave the lowest effort comment you're capable of for that sweet algo juicing. Also make sure your account is not in restricted mode, otherwise you might not even be seeing my videos. I'll provide a detailed step-by-step instructions in the comment section below and the description. I'd now like to thank my patrons and channel members: Ray, Stanforth Hopkins, Christoph Hubinger, Coleman Forestry, Isaiah Garza, Josh Infantine, Rudy Redgrave, Teeny Dragator, Iberospinus, Monitor Man, Jim, Gene Miller, Little Z, JD Trash, Manon Gaudreau, Greg Nonaman, Urban Hermit, and Michael Murphy. These fine folks got to see this video a week ahead of the rest of you. So if you want to be like them, I have exactly one $1 tier on Patreon that gets you a ton of perks the average viewer doesn't get. And there are 2 channel member tiers at $1 and $5 respectively. If you stuck around to the end, then thank you so much for watching, and let me know what other topics in the life and earth sciences I should cover next. I read those comments you goblins make, and sometimes I even reply wryly. But this has been Edge Science, so see you in the next video.